So here we are going to solve the problem from application of differential equation, and our topic is approach to electrical engineering. So I'll first read out the question. We are given a LR series circuit. The current in the circuit containing resistance R and inductance L in series with voltage source battery, and the EMF is given as E, and we have to find out the current. So this is the thing we have to find out. So I'll first draw the circuit for the rough idea. Let us suppose this is a resistor and this is an inductor, and it is connected to the battery source. So this is the battery and having the EMF E. This is the resistor having resistance R. This is the inductor having inductance L. So this is the direction of current. Let us suppose I, and this is the thing we have to find out. So we have to find out I, the value of I. And so this is the LR series circuit, and this is the EMF battery, and we can see that in LR series circuit there are resistor and inductor, and when current is supplied then voltage gets dropped at in the resistor and inductor respectively. Since these are connected in series, so we can write out let VR be the voltage drop across resistor, which we know that it's equal to IR. Similarly, VL be the voltage drop across inductor, so we know this is equal to L times di by dt. So using this both relation, we can find out the value of I, and we know that E is equal to the sum of voltage drop across R and L, which is eventually equals to VL plus VR. That is, we can write VL is equals to IR. Similarly, VL is equals to L times di by dt plus VR is equals to IR. This is the rate of current change. And now if we little modify this equation, we'll get out E by L is equals to di by dt plus IR by L. Now I'll write it above. We don't need these things now. I'm writing this equation, di by dt plus R by L times of I is equals to E by L. So I have rearranged the equation, and if we clearly look at this equation, we will find out that this is the equation of first degree differential equation, which we have already learned previously. It is in the form of dy by dx plus py is equals to q. So this is the standard first order differential equation, and if you compare this with this equation, we will get P is equals to R by L and Q is equals to E by L. And to solve a differential equation, we have two steps. On the first step, we have to find out the integrating factor, which is equal to E times P times dt, which is equals to P is equals to R by L times dt, and if we solve it, it will be equal to E times RT by L. So this is our integrating factor, and the second step is we have to find out the solution. So I'll write down solution is y times integrating factor is equals to q times integrating factor into dt plus c. So I'll put out the substitute the value of integrating factor here. We'll get E times RT by L is equals to, this is integration q is equals to E by L times integrating factor is E times RT by L times dt plus c. Now this is same here, E times RT by L is equals to, sorry, I wrote Y here, it should be I. This is the I here, I. Y is I here. So this will be on integration, we will get E by L times E times RT by L by R by L plus C. Now if we further solve it, it will be, I'll write it above. So this will be I times E RT by L is equals to E by L times L by R times E RT by L plus C. So this cut. Now finally we can write I is equals to E by R plus C into e to power minus RT by L. So I took this this term that side, and finally we'll get this result. So I'll suppose it as equation 1. Now to find out the value of I, we have to first get the value of C. For that, we are initially on, if we initially see that when time is equals to 0, then at that time I is equals to 0. That is, no current is supplied when time is initially when time is equals to 0, then there is no supply of current. So we can write when t equals to 0, I equals to 0. Substituting this value in equation 1, we will get I is equals to E by R, sorry, this is 0 is equals to E by R plus C, and this is equals to C is equals to minus E by R. Now if we substitute this value of C in equation 1, we will get the value of I, which is equal to I equals E by R plus this is minus E by R times e to power minus RT by L. Now if we take E by R common, it will be 1 minus e to power minus RT by L. So this is the value of current, and here the question is solved. Thank you.